Interleaving. The main memory of a computer is structured as a collection of physically separate modules. Each module has its own ABR and DBR, something but address buffer register and data buffer register. So memory access operations may proceed in more than one module at the same time. Thus, the aggregate rate of transmission of words to or from the main memory can be increased. The lower order bit of k bits of the memory address select of a module selects a module, while the higher order m bits name of a m bits are going to be deal with the name of location within the module. In this way, consecutive addresses are located in successive modules. Thus, any component of the system can keep several modules busy at any one time at a time of t. This results in both fast access to a block of data and higher average utilization of the memory system as a whole. To implement this interleaving structure, there must be a 2k modules. Otherwise, there will be gaps of non-existence locations in the address space may occur. Next, we will move on to the hit rate and miss penalty. What is hit rate? The number of hits stated as a fraction of all attempted access is going to be called as hit rate. High hit rate well over 0.9 are essential for high performance of the computer. To decide the performance of the computer, the hit rate should be always over 0.9 or essential. And usually the performance is going to be affected by the action that need to be taken when a miss occurs. So obviously, addressively, the effect is going to be predominantly it's going to be occur when the miss occur is going to be there. So miss penalty, the extra time which is going to be needed to bring the desired location or the desired information into the cache is going to be called as miss penalty. So the performance penalty is incurred because of the extra time which is going to be needed to bring the block of data from a slower unit of the faster unit, to the faster unit, from the main memory to the processor. So during that period, what happened? The processor is going to be stalled. There's nothing but waiting for an instruction or a data, which makes the miss penalty. By referring an example, we can come to know about, or we can see how it's going to get calculated. So a total access time seen by the processor when a miss occurs at the miss penalty. Let me take h be the hit rate, m be the miss penalty, and c be the access information to the cache. So thus we can calculate the average access time experienced by the processor. T average can be given as T average is equal to hit rate into access time plus 1 minus hit rate into miss penalty, which is going to be the formula which can easy to derive the average access time experienced by the processor. Let us see an example. So a block set associative cache consisting of a total of 64 blocks divided into 4 block set. So the main memory content 4096 blocks, each containing 128 words. So here they are going to ask how many bits are there in the main memory address and how many bits are there in each of the tag, set and world feed. So let me discuss about this one. So it's very clearly mentioned that a set associative cache consisting of 64 blocks which have been divided into 4 block set. So number of sets we can calculate it 64 bar 4, that's nothing but 16 bits or 16 sets are going to be there. Number of sets is going to be 16 and set bit is nothing but 4 because already which have been specified as 4 block sets. So 2 to the power of 4 is nothing but 16. So 16 number of sets have been there. So set bit is equal to 4. The number of words are going to be 128 words containing over here, isn't it? So 128 word bits are going to be present over there. That's nothing but 7 bits. So 2 to the power of 7 is nothing but 128 word bits. So 7 bits are going to be there. Then the memory capacity has been mentioned as 4096 blocks, and 4096 blocks containing of 128 words. So that we can calculate the main memory capacity is nothing but 4096 cross 128. So we are aware about that 120 is nothing but 2 to the power of 7. So we can make 4096 as 2 to the power of 12. So that we can get the memory capacity is nothing but 2 to the power of 19. The number of bits, the question which have been asked over this, how many bits are there in the main memory address? So to calculate the memory address, we can take 2 to the power of 19. That's nothing but 19 bits are there in the number of bits in main memory is nothing but a main memory address is nothing but 19 bits. And the tag bit is nothing but what already we come across over there, which is nothing but memory address minus number of words plus set bits. So that we can calculate 19 minus 7 plus 4 is nothing but 8 bits. So the number of words are going to be 7, then set bit is going to be 4, and the number of tag bits are going to be 8. So it's easy to calculate this. It's an example for the to understand or to calculate the tag, set, word fields as well as the memory address. Let us see about the one more problem over here. A computer system has a main memory capacity of a total of 1 mega 16-bit words. It also has a 4K word cache organized in a block of set associative manner with 4 blocks per set and 64 words per block. Calculate the number of bits in each of the tag, set and word field of memory address, main memory address format. So it's known that the capacity has been mentioned over there. That's nothing but 1M. So 2 to the power of 20 is nothing but 1M over here. Then the number of words per block has been given as 64 words per block. So we can take 64. The number of blocks in the cache is nothing but 4K by 64, which have been clearly mentioned, which consisting of 4K words are going to be there per 64 word per block. So 4K bar 64 is nothing but 64. The number of sets which have been clearly mentioned over there, 64 words per 4 block. So 64 by 4 is nothing but 16. So therefore we can easily calculate the set bit is equal to 4. 2 to the power of 4 is nothing but 16. The word bit is going to be 6 bits. 2 to the power of 6 is equal to 64. And the tag bit 20 minus 6 plus 4, there's nothing but 10 bits are going to be there in the main memory address format. So the set bits of 4, word bits of 6 and tag bits of 10 are going to be available in this particular memory.